This is All Things Ansys, a podcast from the technical support staff at PADT. Episode 130, a look at the various connections between Flownex and Ansys tools, along with news and events from the world of Ansys. Welcome. I'm Eric Miller, one of the three owners of PADT, and I'm your host for this podcast. Here we are in October, and I'm really not sure what happened to September. If you listen regularly to this podcast, you know this year in particular, I've been struggling with the passage of time, and really don't know what happened to it all. But the good news is we did 2 interviews in October, so we'll be catching up this month in September, or in October, catching up on these episodes. One thing I did do while I was away, and one of the reasons why I got behind, is I took a road trip from Phoenix, where I live, to Albuquerque to go to their kind of annual tech council tech meeting. Then I drove north up to Breckenridge for a medical device investor conference, then visited our office in Denver, the PADT office in Denver, and then drove back across Colorado, down through the Four Corner region back to Phoenix. It was a fantastic road trip. I fly to those different places because we have offices in those different places. We have one in New Mexico, one in Denver. And I've always driven and said, or always flown and looked down at the ground at the airplane window and said, I need to drive this one of these days. And so I did. I highly recommend it. I could take the interstates and save a lot of time, but I didn't. I took back roads, had a great time in Alpine, in the really high country of Arizona. It's just beautiful up there. Then descended down into the valley, the Rio Grande Valley in New Mexico, and finally got a chance to go out and see the radio telescopes in Socorro. They're actually a little bit west of Socorro. So it's a very large array, it's called. Ansys customer, by the way. And some really cool to just kind of see. You've probably seen them in movies and in advertisings on rock album covers. So there's these big white dishes that move around. And what was really cool is if you hang out for long enough, they actually move them. So they'll do an observation. They'll move the array to look at a certain part of space, take their images, their RF radio images, and then you can actually see them slew and turn and everything to find a new part of the sky. Very cool experience. So that was great. Love driving through the rural areas of Colorado as well. And just some beautiful country through Moab and through the Navajo Nation. Highly recommended. Really, really good time. So we're not here to talk about my road trip. We're here to talk about Ansys. So today we're actually going to talk about 2 tools, 2 simulation products that PADT represents. For over 10 years, PADT has been working to sell Flownex 1D tools in North America. And of course, we've also been working as an Ansys channel partner for over 30 years, or close to 30 years, not quite there yet. Over the past couple of years, both Ansys and Flownex have gotten together to cooperate around creating new connections between the tools to improve system-level modeling accuracy by taking Ansys models and using them to make the Flownex model more accurate, or having better boundary conditions for Ansys models using Flownex to calculate those boundary conditions and combinations of the above. So these connections are at a great point right now. They've really come a long way. Our customers are using them. So we have several customers that are both Ansys and Flownex customers. So we're able to see this live and in person, working on real hardware in turbo machinery in the nuclear industry. It's really kind of cool. So the other thing that happened, besides just kind of being at a good point to talk about it, is one of the main technical people from Flownex is here in the U.S., going around with Miles, who here on the podcast, and our sales team, visiting those customers and talking to those customers about what more they could use in the Flownex tool and how to make the Flownex Ansys connection better. So while they were in the office in between visits, we got them on a podcast. So I'm really excited to talk about it. Let's just go ahead and hear about Ansys and Flownex. Welcome, everybody. For a rare time, we're actually live doing one of these. We're on Teams, but we're in the same room, which you will see if the filtering takes out the air conditioner above us or not, because it's like 104 here in October in Phoenix. But we're here today to talk about fluid thermal simulation with a closely related tool to the Ansys world, Flownex. And we're lucky enough to have Miles Adkins, who's been on our podcast before talking about many things, including Flownex. And then we've also really lucky enough, because they're out here visiting some customers, to have somebody from the company that writes Flownex, Vincent Britz, is here to help us as well to talk about what we're going to talk about. So before we get into what is Flownex and when we're going to the specific topic we want to talk about, which is connecting it to Ansys, Victor, why don't you get a little bit of background about yourself? What's your background? What do you do at MTech?
Yeah, so my name's Vince. I work on the development side for Flownex. I've been using the software now for about 10 years and working at Flownex probably for about 8 of those years.
Great.
The kind of day-to-day stuff that I deal with is writing theory for Flownex. So that'll be adding the mathematics and the physics and putting that together in a neat way that the developers can understand. Trying to add new functionality in terms of new components or maybe new fluids in the software. And then the rest of my time I spend working with customers.
Great.
So that'll be trying to understand what their needs are in terms of the workflows that they're struggling with and trying to find ways to customize the Flownex software to basically help them get through those workflows.
Excellent. So is your background engineering, math, physics?
Yeah, engineering.
Engineering. Great. Excellent. Very good. Okay. Well, Miles, brief introduction of yourself. You've been on before, but if you have a new listener, what is it you do here?
So I'm Miles Adkins. I've been with PADT for, I think, about 6 or 7 years now. I started out on the services team doing engineering projects for different customers. Nowadays, I do a lot of numerical methods, primarily system level thermofluid simulation. So a lot of optimization of systems and thermal fluids and heat transfer.
Great. Excellent. And speaking of fluid thermals and heat transfer, for those that don't know, why don't you give us your quick, Miles, what is Flownex? Why do we love it so much? And where do our customers use it?
Yeah, so I wasn't around at the time that PADT first started using Flownex, but what the tool is a 1D thermal fluid network solver. So 1D CFD, essentially 2D axisymmetric thermal transport. Because it's 1D and it's a network solver, it solves very fast. So when we're dealing with internal flows that are generally safe to assume to be 1D, it can help us iterate on designs and optimize very, very quickly. It deals with single phase, two phase, as well as multi-component fluids. Used widely in like gas turbine design, nuclear kind of systems modeling, safety analysis, instrumentation and controls, as well as some like rocket propulsion. And like I said, generally anywhere where you got internal flows, you'll see folks using Flownex.
Great. And you know what? When I was still doing engineering and I used it, what I loved about it was the user interface was amazing. I mean, we like to say drag and drop. It's pretty dang close to drag and drop to say, here are the components in my system, connect them, put in the parameters, parameterize the parameters, and do all sorts of cool stuff. So we've had a lot of success with it. A lot of our customers have had a lot of success with it, and replacing kind of vertical niche codes that have been around for a long time. That's a lot of what we do. And that's one of the things what we've been doing in the turbo machinery space, right? So that's long legacy there for both us and the Flownex folks. So what we really want to talk about is a lot of work that's been done, and I've actually not been involved in it for quite some time, in connecting Flownex to the Ansys CFD solvers, right? And I think, and maybe also some of the structural thermal stuff, right? So why don't we start there, Vince? Just kind of give us an overview of what does that look like? Why did we even start with why?
Yeah, so the main reason for wanting to do this is that during the preliminary design phase, you're often trying to do rough sizing of equipment. So the main use where we see this being used a lot is in the gas turbine space. So there, for example, you're trying to work out what size do your holes need to be? How many holes do I need? How close should they be spaced together? Right, and you can do 100 CFD runs if you want to, but it's going to take you all month or all year. So it's better just to get the rough sizing out of the way in 1D, but you still want to keep most of the complex physics in place, right? So you still need a really good thermofluid solver, and you're going to need some really good solid models to make sure that you get the conduction right. And if you need to do stress calculations as part of your preliminary design, you need those as well. So from a modeling point of view, it's really important for preliminary design to be able to interface with structural tools like Ansys Mechanical. On the CFD side, use that occasionally, but most of the time for CFD, we glue 1D and CFD together just to give us maybe better boundaries for a CFD model.
Okay. So you would go ahead and kind of set up the problem at kind of a higher level. It reminds me of the first time I worked on something going into space, and I had a very large Ansys mechanical thermal model, and I gave it to a guy that I think modeled it just as accurately with 5 nodes in a finite difference code. So yeah, it's you can really get good answers very quickly that way, and yeah, that's just really good. So. Is it something that the users do to create this connection? What is the tool set that allows somebody to say, I'm going to build my system and I'm going to use Ansys Mechanical to do the structural thermal stuff?
Yeah. So the kind of a way in which we set it up is that we try and streamline the whole workflow as much as possible. Mm-hmm. So as a mechanical user, you're pretty familiar with the mechanical user interface. Probably most of the time you're getting all of your designs from your colleagues in the form of CAD files, and you want to try and simulate the flow. So your traditional workflow is to take that same CAD file and feed it to a CFD tool and mesh it and solve it, right? But in this case, 1D tools don't have a meshing tool, right? You are the meshing tool.
Right.
So to try and help ease that process, and also to try and get the parameters like the diameters, the lengths, the heat transfer areas from CAD files, we don't want to be opening space claim and measuring all of these by hand, right? That's very error prone, it's very time consuming, and it'll bore you to death. Mm-hmm. So the better thing to do is to try and build in some functionality, say into Ansys Mechanical, to read these parameters in and link them directly to the inputs of the 1D flow components. So we've tackled the problem that way, where we try and use the actual Ansys Mechanical GUI mm-hmm. with a bunch of additional extension code. This is customization code that's available for any developers to write and include in the mechanical code. Mm-hmm. So we do this through ACT extensions. Great. And then that allows us to basically build out a Flownex network and superimpose it on top of the 3D CAD file that you're seeing in your mechanical simulation.
Cool. Okay, so you go into mechanical. Let's just assume I'm doing a valve. So I'll read in my valve. I'll identify surfaces and stuff like that in mechanical, and then connect it.
Yeah, maybe a better example is not so much a build, but rather
that's really boring. A valve's really boring. Yeah.
Yeah, we need heat transfer for it.
Right. There's nothing going on there.
so let's say we rather have flows through the little gaps and clearances in a turbine engine, right? Okay. In that case, don't think of the flow over the blades. That's predominantly 3D flow, but right. Class that as almost external flow. Think of the flows inside of the core of the engine. These are the little flows that are flowing between the discs. Wherever there's a small seal, there's going to be a flow through that. Where there's like a small gap between 2 discs, there's going to be a flow there, right? So all of these internal flows in the engine are going to build a really good 1D network. We've got all the tools to handle that on the physics on the flow side, but there's the same type of guys that are interested in that are also really interested in heat transfer, right? Mm-hmm. I mean, the main reason for this internal flow in a gas turbine engine is sealing and cooling. Right. So we need to do that cooling part, and we need to do it well because the reliability of the engine depends on it. Yep. So in that case, what we're trying to do is we're taking things like, let's say we take a lab seal, for example. So a lab seal is a pretty standard shape, and hopefully most engineers know what I'm talking about. So for a lab seal to be characterized well from a 1D modeling point of view, we need some basic geometry about the seal. Maybe we need to know, like, what is the width of one of the teeth? What is the pitch of the teeth? Mm-hmm. What's the clearance of the seal, right? So imagine you're working in your mechanical interface and you've got a CAD file in front of you. You can just add a lab seal component and then click on the edges that would be represented as like this edge represents the length of my the width of my tooth, and then this vertex and that vertex, if we select those two, the distance between that represents the pitch of my teeth, right?
Great. Okay. That's a much better example than my valve. That's really good. Yeah. So I remember doing all that by hand, right? And measuring it in the tool, writing it down, getting it wrong. And then is it parametric? If the geometry updates, will it update the model?
Yeah. So because it's built out in mechanical, mm-hmm. if you update your CAD file, mm-hmm. right, as long as your edge IDs and all of the surfaces remain the same. So basically, if you make a change in space plane, it should propagate through just fine.
Excellent.
In that case, everything should be maintained. So if you go ahead and make a change in your CAD file and re-import that CAD file into mechanical, you should maintain all of the old flow paths that you've already defined, and then anything that's new to your model, you can just go ahead and build only that. So it saves a lot of time when it comes to design revisions.
So once you set up the model, you're basically pushing boundary conditions from mechanical into Flownex, and then Flownex back to mechanical. Is that correct?
Yeah. So once you've got the whole system set up, right, you've built your Flownex model in mechanical, you can easily export that to Flownex. That's done with a click of a button. It uses the Flownex API and basically builds out the network exactly as you built it out in mechanical. It'll even put in a little background image for you so you can see it. You see it superimposed on the screenshot.
Nice.
But when it comes to solving, what the true purpose of this is that we want to get fluid temperatures and heat transfer coefficients from the flow side and push that onto the solid model, and then we want to get the solid temperatures from the solid model and put that back on the fluid model. Right. So that's all done in the background, right? For those who are familiar with mechanical, that's done through UPF, some Fortran code that only the older guys in the office understand. But
Fortran user here.
Yeah. so all of that's done in the background using UPFs, and that handles all of the data transfer. So you pretty much solve in mechanical, and through some magic in the background, Flownex starts solving, and all the data transfer is automated.
It's bidirectionally associative.
Yeah.
Excellent. And then the post-processing you do on the Flownex side for the HTCs and the velocities and things like that, and then mechanical, your normal post-processing.
Yeah, that's right. Yeah, we can represent the fluids in mechanical as thermal fluid elements. They're called thermal beam elements.
Yeah.
That allows you to basically take the fluid temperatures from Flownex and put them in as almost like a meshed element in mechanical. So you can see the fluid temperatures and the solid temperatures in the same GUI if you want. But yeah, for some of your more complex results that mechanical was never really designed to display anyway, things like velocities or even swirl if you're looking at rotating systems.
Good point.
Those are things you're going to want to go into the Flownex GUI and look at in more detail.
Very cool. So one of the objections, Miles, that I think you've run into when you've gone into existing customers and pushed this is like, I've got these correlations I've developed for heat transfer over 20 years. They're my company's secret. That's why I'm using this code that was written by my grandfather. What you can still like put those into Flownex, right?
Right. Yeah. So Flownex has the ability to make custom components. It has integrated scripting, so you can apply your own correlations. And in fact, Flownex has pretty tight integration with Excel. So
even better.
If what you're working on is off of a 15-year-old Excel spreadsheet, and you're trying to bridge that gap between an Excel spreadsheet that's not gone through some great VMV, you can actually pull that into a Flownex model and use the parts of it that are necessary to inform your Flownex model. Yeah.
Excellent. Very cool. Yeah. So kind of the best of both worlds there. You can have your old kind of legacy, deep tribal knowledge, but access it through a new tool.
Yeah. And I mean, there's a huge cost and time saving as well, because some gas turbine design, they don't even do that, where they'll just use tribal knowledge and apply what they think is an appropriate convective boundary condition, and it's fast, but you don't kind of realize when you are gonna as you're optimizing your design, it's hard to optimize based on a guessed value.
That's right.
And so being better informed by actually solving the fluid side is going to save you time in the long run. It's going to avoid those 11th hour redesigns.
Awesome.
Yeah.
Cool. So, I guess, Vincent, if you were going in to talk to a customer, and what would be the one thing you'd want them to know if they were thinking about connecting Ansys and Flownex together to do their simulation?
I probably want to know what are the main applications they're looking for, right? I think we're always trying to look for the pains the customers are experiencing. These niche tools are very dear to many customers' hearts. So we want to try and identify what is the one thing that your niche tool is not doing right now, right? Maybe, for example, you're able to model the flows inside of your engine, but I wish like the solid deforming was a part of my flow calculation as well, right?
Right.
Mechanicals got you back there. It can do structural analysis as well, right? So why not do a structural and fluid analysis and transfer the deformed solid as an updated measurement into your flow model, and then do a calculation that way. This is possible with CFD, but again, you don't have all year to get your results out.
Yes.
So to us, one of the big things we always want to identify from our customers is what are the things you guys wish you could do right now with your internal tools, and to try and work with them to make that possible with Flownex and with couplings with other tools.
Cool. Miles, what would you like users out there to know about this tool that they probably don't know?
So I think what I'll include here. So we've talked a lot about this new workflow coupling between Flownex and Ansys Mechanical. I would also mention that we do have couplings between Flownex and a variety of Ansys tools.
Okay.
There's developer supported couplings to Fluent and CFX as well.
Great.
So if you have those 3D internal flows and you want to capture that in a CFX or in a Fluent, but you want the overall system response, it's awesome to capitalize on the speed of the 1D while not compromising on the accuracy of using 3D where needed.
So just the co-simulation for the 3D in that complicated area, and the rest is really, really fast.
Yep, it's about informing the design earlier, being able to optimize quicker.
Yeah, cool. So where would people go to learn about just Flownex in general, and then the Flownex Ansys connections? It's the best place for that, Miles.
So, I mean, on the PADT website and on the Flownex website, we've got a variety of webinars, blog posts, things like that. I think that there's videos on YouTube, lots of information to find out. And otherwise, reach out to us. We'd be happy to arrange a demo or something.
Probably the best thing is just let us, like you said, Vince, what are you trying to do, and let us guide you a little bit even better to the answers. But you're right, there's quite a few webinars and things out there, and that we've done over the past, and some videos and things. So definitely do that. Well, I'm mad that I can't do this kind of work anymore. This is really kind of cool, and I used to spend hours calculating these values to build the Fluent models back in the day. I don't know if you guys ever worked with that code, but that's what NASA required for space stations. So this seems a lot better. lot better. All right. Well, thanks for taking the time out of your day, and you're between visiting customers and talking to us about it. And hopefully next time you add something cool into Flownex, we'll have you back on and learn more about it. So appreciate your time.
Cheers. Thanks.
Cool. Thank you.
Thanks, guys. So much great capability there, and a lot more to come. If you're interested in learning more about Flownex, or if you already have Flownex and want to learn about connecting it, or interested in how getting Flownex and connecting it to Ansys can be beneficial, a good place to start is on our website, www.padtinc.com/Flownex. We have on that site, it's kind of a little sub-site, product info. There's an FAQ. There's a user forum for Flownex users, and a bunch of links to other resources out there on the web. So it's kind of a central hub for Flownex users. You, of course, can give us a call at 480-813-4884, or send an email to product@padtinc.com. So we'd love to talk to you about Flownex. We love it. I miss using it. It's a beautiful tool. And when you get to using Ansys and Flownex together, it's a wonderful thing. So anyway, let's do a commercial. So we talk a lot about our Ansys sales, support, and training on this podcast, but we also want to make sure you know about our simulation consulting team. An important part of what makes PADT, makes buying your Ansys software and support from an elite channel partner like PADT, is that we also have a full team that uses Ansys software to do consulting. Customers from around the world come to us because of our expertise with the tools and our understanding of engineering fundamentals and how the results from a simulation can be best used to drive your design. Our engineers can provide structural, thermal, fluid, electromagnetic, optical, and multi-physics simulation as a service, and that does include LS-DYNA for the trickier models. We've been doing this for 30 years. Reach out to us at consult@padtinc.com. You can call us at that same number, 480-813-4884. And let's talk about how our engineers can supplement your staff with their simulation needs. Okay, Ansys stock. So as we all know, Ansys is a pending merger with Synopsys. So not a lot going on in the world of stock. It's sitting at $330. It's a few dollars different than what it was last time we talked. Again, as a reminder, the asking price of the deal that was presented when the deal was put out there was $390. So we'll see what happens with the share prices as we get closer. One bit of news on the Synopsys deal that we can share because it's public. I read about it online, is one of the concerns that I had was that Synopsys owns Code 5, which is the biggest competitor to ZMax. Really, those two tools, Code 5 and ZMax, are the tools that people use to do optical system design. Yeah, that wouldn't give people a lot of choice. The one company owning both the major tools. So they're selling it. So they've got a buyer out there that's looking at it. And I think that'll help get the deal to go through. So now we'll be keeping ZMax in the new, whatever they're going to call the new family. And Code 5 will be owned by another group. So other than that, all we have heard from the official channels is that the deal is moving forward and things are looking good. So we'll see what happens. Still on track in the last call that they had about it to the general public to happen sometime in the first half of next year. So there's really no news to report. Being in an acquisition, they kind of keep quiet about stuff. But the press releases in September and the start of October, there's quite a few of them, but they're all kind of those customer testimonials, kind of cool usages of various Ansys family products out there in industry. So that, I always recommend you check it out if your industry is one of those that has a test case like that. One that I really liked was Liebherr, Ansys, and CADFEM, which is the channel partner in Germany and other parts of Europe. They got together and did some really cool things to do what they call enterprise engineering. So simulation engineering at the enterprise level, right? And they're driving it with model-based engineering using Ansys. So kind of how they're transforming how they design and build products. It's actually kind of neat. Even if you're not a big corporation like them, it's kind of a cool look at how you can really change things using simulation. All right, so PADT news. Our big focus right now is celebrating our 30th anniversary, right? It's been 30 years since we started at our old, so we do an annual open house called Nerdtoberfest. And so this year we're combining that with our 30th anniversary celebration. It's October, if you're anywhere near Arizona, it's October 23rd at our Tempe offices. I just checked before starting this recording and 365 people have registered for the event. So that's quite a big crowd. It runs from 4 to 7. It includes food, drink, demos, some VIP speakers that are going to come and talk about PADT being 30. And it's mostly about meeting really cool, smart people, our employees, our customers, our partners. It should be a great event. There should be quite a few people from Ansys here. We don't have an official count yet, but we're really looking forward to that. And some folks from Stratasys as well. All right, let's move on to some publications and talk about the Ansys blog. Something I don't mention enough is how do you get to the Ansys blog? I don't really know. I just type in Ansys blog into the search engine and it takes me right there all the time. So I think it's ansys.com/blog, but the search works better. So Ansys is really starting to get deeper into leveraging AI tools for optimization, solving, and support, technical support. So one of the ways they're sharing with everybody how that's coming, right? It's very early days, but it's starting to really happen, is they have 3 blog posts, pretty good blog posts on it. And so I recommend everybody take a look at this because AI is going to change everything, including simulation. And so we can see kind of the early days of that with the Ansys product family or how they do support. So the first article I recommend is called Combining the Power of Simulation and Artificial Intelligence. Then how Ansys AI Plus models advanced simulation with Ansys. And then the Ansys GPT tool, which is a virtual assistant for simulation queries. So they're basically taking decades of simulation or support data and putting it into a large language model and helping you with a chat bot get your questions answered. It's pretty impressive. So outside of the world of AI, there's a really good article on that we liked it so much that we put it in our newsletter, our October newsletter, September newsletter. And it's on using Fluent to model dolphins, which is really kind of cool. That's right. Fins, to be precise. So do check that out and take a look at the blog. There's probably some other articles in there that interest you depending on your area of Ansys usage. On the PADT blog, we've had 3 posts since the last time we talked. The first one was done by Alex Grishin. It's static equivalent model reduction in Ansys Mechanical. So how to do these kind of like a reduced model of using a static equivalent. It's really one of those things that we do a lot, but not a lot of people talk about or have a lot of documentation around. So useful little reference tool there. The next, as we get into more and more systems modeling in the Ansys world, we call that model-based systems engineering. So that's controls and it's multiphysics and it's all that stuff. So we have an article called Unlocking the Power of MBSE, a high-level overview. So it's a great introduction to what you can do with those tools. And then lastly, the third article that we added was Exploring Optical Design Exchange Workflow between Ansys ZMax Optic Studio and Ansys Speos. So it's basically a way to transfer your lens design over on the ZMax side, which is where you design such things, into Speos, where you can do kind of these ray tracing simulations to look at things like reflected light and spurious light and stuff like that. So pretty cool. A nice tool to speed up that process and combine those 2 tools. Webinar-wise, if you haven't already, please check out our new webinar platform using our website. So we're hosting the webinars on our website now, and we're doing the webinars on Microsoft Teams. And so far, it's been really a much better platform for us. I think that the quality of the recordings and stuff is a little bit better as well. So we moved all the useful old webinars over as well. So the new ones are there and the old ones. It's at www.padtinc.com/webinars. And you can always just go to our website and go to About and then click Webinars as well. So our team has got all of our webinars scheduled through, Ansys webinars scheduled through the end of the year. So I'm going to go ahead and let you know what those are. On October 16th, we've got Maxwell and MotorCAD updates in Ansys 2024 R2. Then we're doing the structural update in Ansys 2024 R2 on the 30th of October. So is that, I guess that's Halloween Eve. Yeah. Then on the 13th, we're doing the optics update for Ansys 2024 R2. We're going to talk about Speos, ZMax, and Lumerical. I'm sure we'll also talk about connecting them together, like we were just saying. That's on November 13th, and on November 27th, we're doing a Fluent update in Ansys 2024 R2. And then I think it's our final structural update. So on December 11th, and probably our last webinar for the year, we're going to do structural updates in Ansys 2024 R2, materials, contact, and joints. So like I said, go to our webinars page or our events page, and you can register for these, or you can listen to the recording after we do them. Event-wise, let me actually bring that up. And let you know what's going on for us in the event world. Not a lot as we finish down the year. Next week on the 16th, so right after this comes out, I'll probably come out really close to that. We're doing the 2024 Southern Arizona Tech and Business Expo. So this is the Tech Council's big event for Southern Arizona. So we'll be there in a booth. It's always a good event. So if you're in Southern Arizona, come out for that. On the 23rd, as mentioned before, we're going to be doing a PADT 30 celebration as part of Nerdtoberfest 2024. So that's October 23rd from 4 to 7 at our Tempe offices. And to learn more about that, you can go to our website /Nerdtoberfest. So padtinc.com/Nerdtoberfest. There's no other Nerdtoberfest out there, so you can also just Google Nerdtoberfest. And then our last event of the year, which is usually our last big event, is with the Arizona Technology Council. PADT is the award sponsor for this, the 2024 Governor's Celebration of Innovation. So this is the big technology award ceremony for the state of Arizona. It's a big gala. We dress up, we eat good food, we sit at round tables and talk, and then people get on stage and say, we look at pretty incredible companies and meet some pretty incredible leaders. And then the after party, there's just a lot of good networking and fun time. So that's the last event of the year. And that's also the last thing I want to talk about in today's podcast. So I want to thank everybody, as always, for listening. Don't forget to subscribe to our newsletter at www.padtinc.com/opt-in. Don't forget to subscribe to this podcast. Like and subscribe. That's what the kids say, right? Like and subscribe on whatever podcast tool you use. And as always, let other people know about the podcast and don't hesitate to reach out if you need anything. Thank you for joining us for the All Things Ansys podcast, episode 130. As a reminder, this podcast is not affiliated in any way with Ansys Inc., and the opinions expressed are those of the people on the show only and not of their current or former employer. For more information, visit www.padtinc.com/blog, and please share your thoughts and questions through an email to podcast@padtinc.com. See you next time.